In this lecture, we take an example of differentiation under integral sign. So the question is evaluate integration of e to the power minus x upon x whole multiplied by 1 minus e to the power minus ax under the limit 0 to infinity with respect to x. So let us try to solve. Let I of a is equal to integration of e to the power minus x into 1 minus e to the power minus ax whole divided by x under the limit 0 to infinity with respect to x. Now, if we want to simply integrate this integral, then this is impossible to integrate it using the as usual integration. But now, so if you want to evaluate this integral, we use the differentiation under integral sign. So for that purpose, we have one variable x in which with respect to that we have to integrate this integral, and there is one more parameter a, and that parameter will help us to do the differentiation under integral sign. So if let us see this is I of a equal to this, so let us apply the DUIS rule number one. Why? Because the limit of this integral is free from a, so we can use the rule number one. So DI dA, which is given by integration under the limit 0 to infinity and derivative of partial derivative of e to the power minus x upon x into 1 minus e to the power minus ax. Now, here we are using the total derivative dda, and here we are using the partial derivative. Why? Because this values are this function e to the power minus x into 1 minus e to the power minus ax upon x. It is the function of two variable x and a. That's why we are using the partial derivative. So let us try to do the partial derivative of this term. So clearly e to the power minus x, e to the power minus x upon x, this is free from a, so we can take outside the derivative. So we have taken which gives us integration under the limit 0 to infinity e to the power minus x upon x, and then the remaining term derivative of 1 minus e to the power minus ax with respect to a. So what is the derivative of 1 with respect to a, which will be 0? And the second thing, what is the derivative of e to the power minus ax with respect to a? So derivative of e to the power minus ax with respect to a is e to the power minus ax. Again, derivative of minus ax with respect to a is minus x. I think this is clear. Let me again explain it. So derivative of 1 with respect to a is 0. Derivative of e to the power minus ax, which is given by e to the power minus ax. And again, the derivative of minus ax with respect to a is minus x. Now, this x and this x will cancel. This minus and this minus will become plus. Therefore, dIdA, which is equal to integration of e to the power minus x into e to the power minus ax under the limit 0 to infinity with respect to x. Now, since the base of both are e, so its exponential will be added. So this e to the power minus x minus ax. And now if we take x common from these two terms, we have minus 1 plus a into x with respect to x. Now we have to integrate this part. What is the integration of e to the power ax? It is nothing but e to the power minus 1 plus ax whole divided by minus of 1 plus a under the limit 0 to infinity. So we can take 1 upon minus 1 minus a, or 1 upon minus of 1 plus a, we can take outside, And if you put the limit, upper limit over here, e to the power minus infinity, because this is x, e to the power minus infinity. And if you put the lower limit, so x will be 0, so it is nothing but e to the power minus 0. And we know that e to the power minus infinity is 0 and e to the power 0 is 1. So we can write down 1 upon minus of 1 plus a uh, multiply by 0 minus 1. So this minus and this minus will become plus. So we have the answer 1 upon 1 plus a, which gives us dIdA, which is equal to 1 upon 1 plus a. Now, this is the differential equation of variable separable form. So separating variables and integrating it, we have d integration of di, which is equal to integration of 1 upon a plus 1 with respect to a plus integrating constant c, where c is integrating constant. So integration of di, which is equal to I, and I is function of a, so we can write down I of a, which is equal to integration of 1 upon x, which is given by log of x, so it is log of a plus 1 plus integrating constant. Let us give it equation number 2. Now, our aim is to find out the integrating constant by using the initial conditions. So what are the initial conditions over here? Now we have to calculate the value of c from equations 1 and equations 2. Putting a equal to 0 in 1 and 2, we have to also put a equal to 0 here. So if you put I of 0, which is equal to log of 0 plus 1, so log of 1 is 0 plus c. So we are getting c is equal to I of 0 from here. C is equal to I of 0. And from the equation number 1, what is the equation number 1? I of 0 equal to integration e to the power minus x upon x into 1 minus e to the power minus x. So if we are putting a equal to 0, it will become e to the power 0. And we know that what is e to the power 0? It is nothing but 1. So which is equal to integration of e to the power minus x upon x, 1 minus 1, which will give us 0 under the limit 0 to infinity. So the overall value of I of 0 is equal to 0. This is from 1. And similarly from 2, I of 0 is equal to log 0 plus 1 plus c, and this log of 1 equal to nothing but 0. So c is equal to I of 0. But I of 0 is what? I of 0 is 0. So c is equal to 0. Hence, from equation number 2, I of a is equal to log a plus 1, which gives us integration of e to the power minus x upon x under the limit 0 to infinity integration of e to the power minus x upon x into 1 minus e to the power minus x under the limit 0 to infinity with respect to x, which is given by log a plus 1. This is the desired result. Thank you.